All right, good afternoon to you all. I hope you are having a nice time, or you've been having great time learning online since morning. All right, so this section is the second part of the video lesson on areas of regular and irregular shapes. And my concern on this particular video is to talk about, excuse me, the area of triangles. And I want to start by bringing forward what we looked at, or what we looked at in the last video. We looked at the area of a rectangle. We saw that to calculate the area of a rectangle, all we need is just the length and the breadth. So the area of a rectangle is length times breadth. And I also explained in that same the previous video that you can solve for the length given the area and the breadth. When you divide the area by the breadth, you get the length. And also similarly, when you divide the area by the length, you get the breadth. So we want to deduce the area of a triangle from what we know. So we are working on previous knowledge. So when you look at this triangle on my screen, rectangle, there are two different rectangles, diagram A and diagram B. Diagram A is a complete rectangle without any division. But in diagram B, I have decided to divide the rectangle into two by adding one of its diagonal. And the diagonal, if you see it, obviously has divided the rectangle into two right-angled triangles. Why right angle? Because you can see that each triangle contains at least one interior angle to be 90 degrees. Now, so what can we deduce? So we can deduce that from that, to calculate the area of one of the right angle triangle, all we need to do is to multiply the product of the sides containing the right angle by half. So what does it imply? So it means since the area of a rectangle, not triangle now, area of a rectangle is given by length times breadth, length times breadth. And we've divided the rectangle into two equal parts. To get the area of figure 1, all I need to do is multiply the area of this rectangle by half. So when we say product of sides containing the rectangle, that is H and B. So in the part of the rectangle, we call this H the length, while we call B the breadth. But in this case, I have changed the length to height. Why? Because this is now a triangle. And from there, we can go ahead and say that therefore the area of a triangle is half base times height, which can also be written in short as 1/2 BH. Is that taken? All right. So let's take an example. It says calculate the area of the triangle shown below. So in this case, the height is given as 9 centimeters, while the breadth is given as 12 centimeters. So all we need to do is apply the formula. Now, the two sides containing the right angle measure 9 centimeters and 12 centimeters. Therefore, the area of the triangle is half times 9 times 12, which is equal to 54 centimeters squared. 54 centimeters squared, of course. 2 in 12, 6. So 6 times 9, 64 centimeters squared. Example 2. Calculate the height of a triangle whose base and area are 8 centimeters and 20 centimeters squared respectively. So in this case, we want to calculate the heights given the base and the area. Now we'll go back to the formula. The formula to calculate the area of the triangle is half base times height. Substituting the values given, the area is 20 centimeters squared, and the half is repeated. The base is given as 8 centimeters, and height is unknown. So when we solve further, this is 20 centimeters squared. 2 in 8 is 4. 4 centimeters times h should be 4 centimeters. Then dividing both sides by 4. When you divide here by 4 and you divide this side by 4, you get, we arrive at this next equation. H equals, because 4 will factor out 4, you have to cancel 4. You have H equals 20 centimeters squared over 4 centimeters. Or let's say dividing both sides by 4 centimeters, so that centimeter will also cancel centimeter here. And this centimeter, we cancel one of the centimeter up, then we left with H equals 5 centimeters. I hope that wasn't confusing. All right, so therefore the height is 5 centimeters. Okay, I hope very simple, very simple. All you need to know is just memorize for now the area, the formulas, calculate the area of the triangle. Memorize it for now. All right, next we're looking at area of parallelogram. So this is the picture of a parallelogram. It's a shape that has its opposite sides to be equal and parallel to each other. Just something like this. This is true. All right, so that is a parallelogram. Okay. Let me draw my parallelogram to look more neater than this. This is looking zero. So I hope you are following me. A parallelogram is a four-sided figure with two of its sides parallel to each other and equal. The opposite sides parallel and equal. These two sides are parallel and equal in length. These two sides are also parallel and equal in length. That's why it's called parallelogram. All right, so we labeled the parts. We call this B and this side H. This B represents the base and this represents the height. So the area of the parallelogram P equals area of rectangle, which is just equals the base times height. All right. In the diagram above, the height of the parallelogram is H and its base is B. So in general, the area of parallelogram is equal to base times height. The base of the parallelogram equals area divided by height. And the height of the parallelogram is equal to the area divided by the base. So this is not times, divided by the base. All right, having said that, let's look at an example or some examples. Say calculate the areas of parallelogram in the figure below. A. For parallelogram A, we are given the base as 7, all dimensions are in centimeters, 7 centimeters, while the height is 5 centimeters. All right. So substituting the formula for calculating the area of the parallelogram A is equal to base times height. Base times height. And that is equal to 7 centimeters times 5 centimeters. And that will give us 35 centimeters squared. Correct. Oh, sorry. That is equal to 35 centimeters squared. Okay. Is that taken? All right. So let's solve the next second question. That's 25 centimeters squared. Example 2 says in this case, the base is what do you think the base is? What's the value of the base? 5 centimeters, that's perfect. And the height is 3 centimeters. Therefore, the area is equal to what? Oh, this is great. So even without putting pen and paper, you're able to say the answer correctly. That is very smart. So the area will be 5 centimeters times 3 centimeters. 5 centimeters times 3 centimeters. And that is equal to 15 centimeters squared. Correct. 15. You can see it's very simple. 15 centimeters squared. Please endeavor to always remember to add the squared to the final answer. All right, because that is area. Area is squared in it. I said it in the very first class. Finally, item C, question C. Question B. Question C, we have the base as Good. What is happening? What is happening? I'm tired. I need to rest. But I have to finish this video. So we have the base as 8 centimeters, and the height is given as 6 centimeters. All right. So the area is equal to 8 base times height. We call the formula base times height, which is equal to 8 centimeters times 6 centimeters. And that is equal to what? 8 times 6 is what? 40. Wow, you guys are cool. They're very good. 48 centimeters squared. So you can see how I went about the solution of to these problems very easily, very soon. Okay, now next we're going to be looking at area of a trapezium. So this is the figure, the shape, or the picture of a trapezium, and it says ABCD is a trapezium in which AB, like AB, is parallel to BC. The diagonal BD divides the trapezium into 2 triangles. You can see, divides it into 2 triangles. The height H is the same for both triangles. So both triangles has same they have the same height H. Now the area of trapezium ABCD is equal to area of right angle triangle ABD. This is a right angle triangle. Right angle triangle ABD plus triangle BCD. And just by what you've just seen right now, not quite long, you have the area of triangle, right angle triangle ABD as half AB times height, half AB times height. The AB here represents the base of triangle ABD, plus the area of triangle BCD is equal to half DC times height, which is the base of triangle BCD, same height, but BC represents the base. So by inspection, when you inspect this expression properly, you observe that half is common to both terms. So you can factor it out to the left. H is also common to both terms, so we can factor it out to the right. Now what do you have left inside? AB plus DC. Now from the diagram, we've represented AB as small a and BC as small b. Therefore, the area of the trapezium is half A plus BH. Half A plus BH. A is usually the shorter parallel side, while B is usually the longer parallel side. H is the height of the trapezium. Example, calculate the area of the trapezium ABCD in the figure below. Alright, so that is the trapezium ABCD. Length 6 centimeters at the top, 13 centimeters at the base, and 8 centimeters as the height. So the solution goes thus. So the diagonal AC divides the trapezium into 2 triangles. Like you can see that. The height of each triangle is 8 centimeters. So each of the triangles has same height as 8 centimeters. Area of triangle ACB is equal to half base 13 times height, which is 52 centimeters squared. While area of triangle ACD is equal to half, this is ACB, half base 6 centimeters times height 8 centimeters, which is equal to 24 centimeters squared. Therefore, the area of the trapezium ABCD is equal to 52 centimeters squared plus 24 centimeters squared, which gives 76 centimeters squared. Okay, and next, before we end the lesson, we're looking at area of circles. So here the circle, its radius R and diameter D, center O. So a diameter, of course, you know, is a straight line that runs from one point on the circumference of the circle to another point on the other side of the circle in circumference, passing through the center of the circle is a special chord, while the radius is half of the diameter. So here is the area to calculate the formula to calculate the area of a circle, pi r squared. where pi is given as 22/7. Pi is not equal to, remember I said in the previous class, pi is not 22/7, but it's approximately equal to 22/7. And the diameter of the circle is 2r, which means where r is radius. So if diameter is 2r, the radius is what? Diameter over 2. Good. So that, therefore, the radius is going to be equal to d over 2 diameter over 2. Is that taking place? All right. Then let's look at examples. The first example says, find the area of the circle whose radius is 3.5 meters. Take pi as 22/7. So go ahead and substitute. Pi is 22/7. Our formula is pi r squared. Pi is 22/7. R is 3.5 squared. And 3.5 is a mixed fraction. When you convert it to a proper and improper fraction, it give us 7/2. And there's a square to it. So that means 7/2 times 7/2. Okay. So 22/7 times 7/2 times 7/2, you get 77/2 meters squared, which is equal to 38.5 meters squared. So that is this is the a step before the final answer, and that was quite very easy, I believe. And number 2, the area of a circle is 126.5 centimeters squared. Find its radius correct to two decimal places. Solution. So we call also the formula of the circle because 2 pi r squared rather. And the area is given as 126.5 centimeters squared. Equal to the pi is taken as 7 and r is just r squared because it's unknown. Okay. So when you solve for that, 126.5 is there is same thing as 253 divided by 2. Okay, that is when you convert this to an improper fraction, which is equal to 22/7 r squared. So 253 times 7 equals 22 times 2 times r squared. Do you know what has happened here? We cross multiplied. That is 252 or 253 divided by 2 equals 22/7 r squared. Okay, so when we cross multiply, you observe that you have 253 times 7 times 7 equals 2 times 22 times r squared. Did you see that? So that was how we got the this particular line here. This particular line. So going further, we solve, multiply these 2 and multiply these 2. So when we multiply 253 by 7 and multiply 22 by 2, that will give 44. I'll break that to the lowest term, that is 169 over 4. Then you take the square root. Please note that whenever you have anything like this, a term or an equation like this, r squared equals 9. To solve for r, what we do always is to take the square root of r squared. And when you're taking the square root on the right hand side, you must always have a plus or minus sign. So therefore, r is equal to plus or minus 3. Okay, so that is a rule. When you get to senior class, you understand better when you're taught laws of indices. So whenever you're trying to eliminate squared, you apply square root. If you're trying to eliminate square root, you apply square root. So we try to eliminate the square root here, the square here, so we apply square root to both sides, and that will give the square root of 161.4. So you can see, if you observe, we ignored the negative sign here because we are dealing with length. Of course, radius is length, and length cannot be negative. That was why you didn't see me adding any negative sign. But if you try to be algebra or points, you have to add the plus or minus or root. Okay, so when you solve and simplify, you get the answer 6.35. All right, so and here's the classwork. Please pause this video right now, attempt the classwork, and post your solutions. I would like to see the solution before the end of the class. Is that taken? Last but not least, we are looking at applied problems, area of irregular shapes. So the first example, irregular shape, I've explained from the beginning of the lesson, the previous video. That's irregular shapes are shapes without definite. They are shapes that have no definite pattern. Has no definite pattern. So here are examples. Calculate the area of the shape below. All measurements are in meters, and all angles are in right angle. So we have this shape. This is 7. All right. Here's 3. Here's 8. Here's 2, and here's 4. So by go ahead to solve. We divide the shape into 2. So this is 3 by 3, and this is 6 by 10, and here is 2 by 4. So go further, solve, simplify, get your answer. All right, please attempt the classwork, and the assignments will be due the next class on Friday. Attempt, so you have 2 classworks to attempt, the first, and here is the second classwork. I'm expecting to receive these 2 solutions to these 2 classworks, to the 2 classworks before the end of the class. Before the end of the class, please watch the video carefully and attempt my exercises. Thank you for your patience. You have a wonderful time.